Okay guys, so we're going to start a new chapter, and as the intro we're going to watch a video, and then I made a detailed intro sheet so that you guys can let me know how you like it in class on Wednesday. But what we're going to be talking about in chapter 6 is ratios. We're going to get into unit ratios, rates, percentages. We're going to get into all sorts of good stuff. So this is an intro to a concept that is called a ratio. And a ratio is the quotient of two, I'm going to underline that, two quantities. So it's no different from a fraction, except that a fraction is sometimes written using, except that a ratio is sometimes written using notation other than fractional notation. So this is what we're used to seeing as a fraction, but it's also considered a ratio. The other ways we're going to look at these ratios are 1 to 2, and this is read the same way, 1 to 2. So it says write each ratio as a ratio of whole numbers using fractional notation, and you want to write that fraction in simplest form. So what we're going to do is I have the answers over here, so we're going to work it through, check our answers, then you can pause the video, try these, or here's some for you to try, and then we'll go over them. Okay? Okay, so 25, the number that's first goes in the numerator. The second number goes into the denominator. All right? I can easily tell that 5 will go into both of those. So I'm going to divide the numerator and the denominator by 5. So that'll give me 5 over 30. And I can tell again that 5 is going to go into both of those. So I'll divide numerator and denominator by 5 again, and that will give me 1 over 6. All right, 8 1/10 over 100. Okay, so you never will see a decimal embedded inside a fraction, either in the numerator or the denominator. So what we're going to do is we're going to multiply both the numerator and the denominator by 10. Now this is our rules for multiplication. I know that if I multiply by a power of 10, I get to shift that decimal place over to the right, in this case 1, because I have 1 0. So that will be 81 in the numerator, 10 times 10 is 100 in the denominator, and that is in simplest form. Last one, 35 meters over 100 meters. Now you'll notice in the answer key that we don't have the meters. If you have units that are the same in the numerator and the denominator, let's say they cancel out, but you don't need to include them in your final answer. So since we have meters and meters, these are both divisible by 5, so I'm going to divide the numerator and the denominator by 5. 35 in again. And then you'll have your 7 over 20. All right, so pause it if you need to. Take a few minutes. Try doing these 3 on the bottom. Unpause the video and see how you did. All right, so 16 to 24, the first number goes in the numerator, the second number goes in the denominator. Now upstairs we were dividing, but let's try simplifying in a different way. So if you want to look at 16 as 2 times 8, 24 as 3 times 8, 8 over 8 is 1, and then you're just left with 2/3. 6 ounces goes in the top in that numerator. 16 ounces goes in the denominator. And we said if the units are exactly the same, you don't need to rewrite those out. So 6 over 16, they're both even. If you want to write it this way, this is the way you want to think about it, you can simplify that as 3 divided by 8. 3 is to 8. And the last one, $32 over $100. Those dollars are the same upstairs and downstairs in the numerator and denominator. So again, those can just cancel out. All right, let's try simplifying this as a different way. Let's try doing it as the product of primes. Just a different way to show you all the methods that we've been going over in class. So that's 2 times 16. Oh, there's going to be tons of 2's with this. 2 times 4. more. Wow, look at all those 2's. So 32 is 2 times 2 times 2 times 2 times 2. 100, not quite as many 2's. I'm just going to break these down into its product of primes. So 100 downstairs will be in that denominator 2 times 2 times 5 times 5. And then we can loop these 2's. That's 1. That's 1. So it looks like I'll have 8 in the numerator and 25 in the denominator. And I don't need to write those dollars because I have dollars in the numerator and dollars in the denominator. Okay. Hopefully you did really well with that one. Use the given rectangle to shown to find the following. Okay, so they want a ratio. The width, which is the shorter side, to its length. Okay? So I'm going to go ahead and write it as a fraction. Now you could write shorter side, and we'll put our feet in there, to larger side. You could do it that way. As a fraction, 5 feet in the numerator, 7 feet in the denominator. We don't need to write those units because they're the same. So 5 over 7. The ratio of its length, which we already said is 7, to its perimeter. Okay, well, we can do that. We know we need all the lengths of the sides if we're going to find perimeter. So 7 plus 7 plus 5 plus 5. If you pull out your calculator, that'll be 24. So you can write it like that. Or if they ask you for it in fractional form, right, it would look something like that, but since the units are the same, we can cancel those off. So 7 over 24. All right, take a pause. Try question 4 and 5, and turn it back on and see how you did on it. Okay, here we go. The ratio of its width, which is the shorter side in this case, to its length, which is the longer side. So width to the length, okay, as a fraction, we'll have 3 feet over 11 feet, but we don't need to include the feet since they're the same units in the numerator as they are in the denominator, and that's reduced. The ratio of its length to its perimeter. Okay, length is 11 feet. Its perimeter, 11 plus 11 is 22. 3 plus 3 is 6. So it looks like we're going to have 28 feet. Whoop, I should put that over here. 11 feet to 28 feet. Okay, and then this is how it's written, sorry about that, as a fraction. And the units cancel because they're the exact same in the numerator as they are in the denominator. All right, I'm hoping that was okay, right? And that was pretty decent. All right, here we go. So let's review. A ratio was the quotient of 2 quantities, any 2 quantities. Now we're getting a little bit more specific. A rate is used to compare different kinds of quantities. Okay? Helpful hint. When comparing different quantities with different units, you need to write the units as a part of the comparison. They're not going to cancel out. The units do not divide out unless they are the same. So this is what we were just doing. These are the ratios that we were just covering. Like 3 inches to 12 inches is 1 over 4. Since the units were the same, they divide out. Now for rates, that's what this is. We're going to be looking at different kinds of quantities. For example, if someone ran 2 miles in 20 minutes, okay, these aren't going to cancel out. So we need the miles in the numerator, the minutes in the denominator, but we can still reduce that fraction. All right, so let's write this out in simplest form. So we'll have $2,160 in the numerator, 12 weeks in the denominator. Okay, the dollars and weeks aren't going to cancel. All right? They are both divisible by 12. Okay, so pull out your calculator and try that. Try 2,160 divided by 12, and you would get 180. You could put the dollar sign here or just write dollars. That's how they write it in the book. And then over 1 week. If you divide both the numerator and the denominator by 12. I just want to show you that you write the units in, but you'd also reduce those fractions. All right, 360 miles in the numerator over 16 gallons of gas in the denominator. Okay, these are not the same. So this is a rate, and you're going to have to leave those in your answer. I'm just letting you know these are both divisible by 8. You can check that on your calculator. So then you'll have what the answer key says. 45 miles divided by 2 gallons. So if you're going 360 miles on 16 gallons, that means you're going 45 miles for every 2 gallons. All right, here's some for you to try. So take a pause, try them, and then we'll check them together. Go ahead, try them. All right, here we go. 4 inches of rain in 4 hours. Okay, so 4 inches of rain in 18 hours. Okay, so this is a rate because my units aren't going to cancel. I can reduce these though. They're both divisible by 2. So if we divide the numerator and the denominator by 2, and the numerator will have 2, and the denominator will have 9, and now we have to include our rate, or our units for our rate, inches and then hours. All right, let's try one more. 18 gallons of pesticide for every 4 acres of crops. Again, these are different, so they can't cancel. But we can simplify the number portion. They're both divisible by 2. So there'll be 9 in the numerator and 2 in the denominator. All right. All right, clipping right along. Now this is the stuff that I actually really like, because once you start becoming a shopper, you're going to be using unit rates quite a bit. And if you go into any store, if you go into Wegmans or Walmart, they legally have to post a unit rate under every product. So let's check out what it is. So a unit rate, now keep in mind, it's a rate. So the quantities, just like we listed here, there are different kinds of quantities. Okay, so since it's a rate, the quantities that you're comparing are going to be different. Okay, like miles per hour, dollars per ounce. Okay, the quantities will be different. But a unit rate is a rate where the denominator is 1. So basically, you just pull out your calculator and you check your answer. That's pretty much what you're going to be doing. Okay? All right. So my helpful hint for you guys, getting my calculator out. My helpful hint is when you see, for example, 55 miles in the numerator and 1 hour in the denominator, we usually, instead of say divide or numerator and denominator, we usually use the word per while we're talking about the unit rate. So example, this can be written as 55 miles in the numerator, 1 hour in the denominator, but it's read as 55 miles per 1 hour. Right? I know you guys have heard of that. To write a rate as a unit rate, you just need to pull out your calculator and divide. It's very, very easy. All right, write the following as a unit rate. All right, so if we have $31,500 every 7 months, how much money will we have per month? So if you pull out your calculator, do 31,500 divided by 7, you're going to get 4,500. That's in the numerator. 1 will be in the denominator. But typically, if you have 1 in the denominator, it's just read as $4,500 per month. That's usually how you're going to see it. All right, let's look at a product. If we're going to spend $2.40 for a 12-ounce product, how much are we spending per ounce? So just pull out your calculator and you'll get this. So we know it's over 1, and that will be dollars per ounce. So 20 cents per 1 ounce, or per ounce, is what we're spending. That should make sense, right? 20 cents per ounce times 12, that's going to give you $2.40. Now this is a very typical label that you'll see at Walmart or Wegmans. They're going to tell you the total price. They're going to tell you how much you're getting for that price. And then the most important thing is they're going to tell you what the unit, it's a unit rate, but stores will call it a unit price. And it's going to help you be a very smart shopper, because it's going to allow you to compare sizes for the same type of product. You're going to start using it, I guarantee it. It's the way to be a smart shopper. Okay, so unit price means dollars in the numerator, the number of units, or how much you're purchasing. No joke, I was at Wegmans, okay? I typed this up a few days ago, so this week. So at Wegmans, the cost for an 11-ounce bag of Doritos right now is $2.50. The cost for a 16-ounce bag of Doritos is $4.19. So which is the better buy? Now, it's very easy when you're shopping at Wegmans, because you just look at the unit price, which is listed right below the product. But what a lot of people think, and it's very deceiving, that the bigger the bag, the cheaper, the better the bargain, right? Okay, so I did the workout here, but this is what we're going to do. This is what the tag says. So we're going to spend $2.50 for an 11-ounce bag of Doritos. So if you pull out your calculator, that's going to be just about 23 cents per ounce. So for every ounce we're purchasing, we're spending between 22 and 23 cents per ounce. Now check this out. If we're buying a 16-ounce bag, it's $4.19 for a 16-ounce bag. If you pull out your calculator and calculate that out, you're paying, look how much, 26 cents per ounce. So which is a better purchase? Believe it or not, it's the 11-ounce bag, because you're spending less amount of money per 1 ounce. And that's why the unit price is so important when you're comparing prices of the same kind of product, but just the different quantity. So I said, do you notice that it's cheaper per ounce for the 11-ounce bag rather than the family 16-ounce bag? So you got to be a smart shopper, and we'll talk more about this on Wednesday. All right, here goes. Find the unit price. So take a minute, turn this off, and see how you do on it. And then we'll come back together and work it through. So find the unit price for a 32-ounce jar of pickles that costs $1.89. Okay, again, these are just some examples from the grocery store. So the amount we're spending is in the numerator. The amount we're purchasing is in the denominator. Okay, so you pull out your calculator. Okay, I've got my calculator here. I put $1.89 divided by 32. And this is what I got on my calculator. 0.059. Now this is going to be dollars per ounce. Per 1 ounce. But the unit price will look like this. 0.059 per ounce. So you're spending just about 6 cents for every ounce of pickles that you're purchasing. All right, let's compare generic to a generic store brand versus a label brand. So at Wegmans, an 18-ounce box of Cheerios right now costs $3.99. And we're going to compare it to a 14-ounce bag of the Wegmans Toasted O's. Find the unit price of each and decide which is a better purchase. Okay, so the unit price for Cheerios, it always goes dollars in the numerator and how much you're purchasing in the denominator. Okay, so pull out your calculator. $3.99 divided by 18. And I asked you to round it to 3 decimals because that's what Wegmans does. So they'll put $0.222 for every 1 ounce, or this $222 per ounce. Okay, now let's check out the Wegmans Toasted O's. Here we go. So it's $1.99 for 14 ounces. It's a matter of just pulling out your calculator. This is on the calculator portion of the final. So this, I got $0.142 per 1 ounce. So I'm hoping you'll see in this case it's pretty clear that if you can't tell taste-wise the difference between the Wegmans brand and Cheerios, that you're definitely getting a better buy with the Wegmans brand. So this is going to help you be a smart shopper. It really is. And we'll talk about this in class. So here you go. You have a video worksheet. So when you come into class, we are going to go over this. So make sure that